Okay. Good afternoon, everyone, and welcome to SEAC's project presentation on the strengthening and preservation of the Many Glacier Hotel in Glacier National Park. My name is Philip Taylor, and I serve on SEAC's Education Committee, which organized this presentation. We're being webcast today from JVA's office in downtown Boulder. We're excited to have you with us today. We're excited to be joined by two engineers who I'm fortunate to call my colleagues. I get to work with them on a daily basis. Ian Glaser is a structural engineer who leads JVA's Historic Preservation Group, a team that combines technical aptitude, creative thinking, design creativity, design sensitivity, and effective communication to deliver successful preservation, rehabilitation, stabilization, and investigation projects. Ian has been focused on historic preservation work both regionally and nationwide for the past 16 years, and is a regular presenter at Colorado Preservation Inc.'s annual Saving Places Conference. Ian worked for more than a decade on the phased rehabilitation of the Many Glacier Hotel, helping save one of the National Historic Trust's most endangered places. When he's not saving historic places, Ian coaches youth flag football in the spring and the fall, and is planning to become a position coach on a youth tackle football team this fall. He has a young son and a daughter who both play football. Brett Robinson completed his studies and began his career in Michigan before coming back home to Colorado and joining JVA in 2007. Brett is a senior project manager with over 20 years of experience, specializing in the design of new and existing K-12 education facilities on the Front Range and beyond. Brett prepared the historic structure assessment for the Nunn Water Tower, a task that had him climb 20 feet up a ladder to inspect the condition of structural steel. Brett was the co-project manager for one of the final phases of the Many Glacier Hotel project, helping engineer the unique lateral force-resisting system of the hotel's lobby wing. When he's not climbing up water towers or strengthening historic hotels against earthquake loads, Brett enjoys running marathons. Brett has finished marathons in 19 states. So here's a look at our agenda today. We have about an hour and a half program for you. I'm in just a few short minutes going to turn it over to Ian Glaser. We're going to go through the presentation on the Many Glacier Hotel. We're going to take a quick break for some housekeeping notes while I can introduce some of the upcoming events on SEAC's calendar. And then we will return to Ian and Brett for some questions and answers. Throughout the presentation, anyone who has any questions for Ian or Brett, feel free to add them to the chat. Thanks. And with that, we'll welcome Ian.
Can you do that? You think I can set this on the table? Okay. Thanks, Phil. Fun fact about Phil, he was a reporter before getting his master's degree in structural engineering and joining JVA a few years ago. And thanks to everyone for inviting us and joining us. Bear with me, I'm trying to flip a slide. Okay, hang on everyone, we're almost there on the technical. I believe Irina's on the call, and thanks to her for inviting us. I'm also joined by Dave Miller, who is our drafter on the second phase, and Christine Britton, who is a project engineer on the second phase of the project. And also here is Richard, SEAC's IT guy, who's helping me here as I get my feet under me. Okay, so here's the outline for today. We'll talk about the history and get you oriented, and then our scope will highlight some constructability issues that were in the front of our minds during the design, and then get into the meat of the presentation, which is some of the structural design challenges and the solutions we came up with. So here we go. This part of the presentation goes pretty quick. I have a handful of historic photos to show you, to just give you a sense of the setting. That's the hotel there, perched on the edge of Swift Current Lake. It was built in between 1914 and 1917 by the Great Northern Railway, and that's right about the time that the National Park Service was formed. Woodrow Wilson was the president at the time, and similar infrastructure was being built by railroads at other parks, for example, down at the Grand Canyon. Glacier National Park is in the northwest corner of Montana. It's on the east side where it's sparsely populated. It's very close to the Canadian border. I remember being up there and the only thing I could get on the radio was hockey games. And the big acreage to the east of the park is the Blackfeet Nation, the Blackfeet Indian Reservation. Within the park, Glacier is on the east side, which is sees many less tourists than the west side does. The yellow line sort of bisecting the park in two is the Continental Divide. One can get there over the Going to the Sun Road, which is very much like Trail Ridge Road. It's not for the faint of the heart. Or one can drive around the park to the south and enter from the east side, which is what we normally did because we were doing our site visits in the shoulder season. The hotel's at about 4,900 feet, and Logan Pass at the top of the divide's 6,600 feet. Hang on, things are popping up on the screen. Here's a plan view to get the engineers oriented. So north is to the left, and the kitchen and dining, employee areas, and the shops are on the left. Can you all see my mouse? Okay. In the middle in beige, the T-shaped section is Annex 1. The iconic lobby is just to the south of the annex, and then on the far south end is the second guest room wing called Annex 2. The lake is to the west or to the south, and then the hillside goes up to the east. The hotel is about 140,000 square feet. It's timber, log, dimension wood framing, and then the foundations and the chimneys are stone masonry. The building, most parts of the building are 4 stories with a fifth walkout level at the basement on the lakeside. And there's balconies on all sides of the hotel. There's the grand masonry chimneys in the public areas. You can see 2 of the lobby chimneys in this historic photo. And this is a very early photo. The South Bridge and Annex 2 haven't yet been constructed. Here's a more recent picture with the South Bridge and that second guest wing, Annex 2. And yet another view where you can see Swift Current Lake in the background. Finally, this is the lobby, and this is the first guest wing, Annex 1. And then in the far background, This is the kitchen, and here's the kitchen chimney. Take a look at the kitchen chimney in this photo. It's quite tall, and it has the diagonal steel strut. This is a porte-cochere that was installed at some point in the mid-century. It's not historic. It was part of our project, and we kept it. And then here's the lobby. It's a 4-story space with an atrium. Those logs travel from the roof framing all the way into the basement, which is below the level you're seeing. And then here's another look at the lobby. Some point in the 50s, it kind of reminds me of a set for like a Sean Connery, James Bond type movie. And here is the original helical stair. The lobby basement and the lobby first floor had been heavily modified over the years to accommodate a gift shop and cafes and whatnot. The helical stair, the rumor has it, was removed and put into Swift Current Lake. We did, at the very end of our project, reconstruct the helical stair with some funding help from the Glacier Conservancy, which is the nonprofit funding arm and partner with the park for Glacier National Park. And there's Franklin Roosevelt. Here's the dining room. We'll talk about this in a minute. Historic photo with the same Asian influenced lighting fixtures. Here it is after it had been renovated, the ceilings put in, light fixtures changed. I'd imagine those people to be part of the staff. And here's yet another picture of the dining room, the wagon wheel light fixtures, the ceiling concealing the trusses. Those expansive windows are gone, the pergola is gone, and you can only see the lower half of the chimney. Richard, I'm sorry, I lost my, when those little chats are popping up, I lose the mouse. Hang tight. Okay.
And it shows up down here.
Thank you. Thanks a bunch. That's Richard. He's we couldn't do this without him, obviously. And these last couple pictures here, they just give you a good sense of what the environment's like in Glacier. It's an alpine environment. There's a lot of snow. It's cold. And the building was suffering because of its, it's basically under snow all year. And a lot of the exterior framing was deteriorating. And then it was built empirically, so there were some significant deficiencies in the lateral system, and that was really the focus of our work, and we'll talk about that shortly. The snow is reported to reach the eaves of the roof at times. Here it is at the 3rd story. And this particular wing had begun to subside towards the lake. It was tilting towards the lake, in part due to the snow that built up on its uphill side. And here's another springtime picture. You can see how the snow is sort of reaching up to touch the upper levels of the guest wing. And I'm glad I looked at my notes. I wanted to show you this chimney, which at some time between the two pictures, the upper section had been taken down and the strut removed. Okay, part 2. We saw some of those interior renovations in the mid-century. The second half of the century was really just a series of Band-Aids to keep the hotel functioning In 87, the hotel was designated. And then the project really, I guess, got serious in 96 when the National Historic Trust listed it as one of America's most endangered places. And again, that was related to the deterioration and these deficiencies in the framing and the lateral systems. Soon after, another team performed an HSR and a handful of emergency stabilization measures. Those were primarily related to the exterior. So a new roof, some siding repairs, the tilting guest wing was pulled back to plumb with cables and a new foundation put in. And the exterior balconies were essentially reframed with tube steel. This is our team's scope. We had sort of a discovery period for a few years and then 2 design periods and 2 construction periods. So really 2 phases. Each phase was about 70,000 square feet. First phase, even though it was about, the work was about half and half, the first phase was around 12 million. And the park was fortunate to take advantage of some construction costs right after the recession that allowed them to get a lot more bang for their buck. The second phase was about twice the price, and then the remaining dollars went towards some smaller projects like hazardous material removal. Here's our orienting plan again. If you can see my mouse on the north end, the dining, the kitchen, and the employee area. My mentor, Dan Cook, did the design here. I was the project engineer and did the lateral design for the annex. Brett, who's with us here this afternoon, tackled the lobby, which was frankly the most complicated. And then Christine, who's on the call, worked on Annex 2. And Dave Miller, our drafter, did all the drafting for this south half of the building. We did the whole project in AutoCAD, and nowadays we're doing these in Revit. This is a great slide. This particular graphic is probably 10 years old, but it's staggering. So the backlog in the Park Service is about $10 billion. The available funding per year is on the order of 150 million. So it's not that easy to get funding for a project like this. There's great buildings like the Many Glacier Hotel in many of the parks. Many of them need help, and for that reason, sometimes these projects are phased and they move a little bit slower than you might be used to. So the whole design team was led by Anderson Hallis, and they worked with the park, and the park worked with the people in Washington to make a case to get this project off the ground. And the trick of it was, and it was a great idea, it was positioned as a life safety project, and that helped prioritize it higher than other projects in the queue. And so once it gained attention and was going to be funded for these serious life safety issues, the faulty knob and tube wiring, the structural issues, there were some dead-end corridors, so fire suppression, those kinds of things. Anderson Hallis said, oh, by the way, when we do all this work, let's reinstate all the historic finishes that were lost over the years. Here's some more slides we'll go through pretty quickly. These were all something we thought about as we did the design, prepared the drawings. It's not quite like a normal project because of the handful of constraints. We talked about the location before up here, right near Canada, and it's about 3 hours from Kalispell and 3 hours from Great Falls, which are the sort of biggest cities where you can get supplies and labor. The reservation here is just outside the park. It's this entire area is very sparsely populated. limited housing, hardly any hotels. Most of the construction crew either had a long commute or they stayed in trailers around Babb. The park snowed in the winter, and it's also closed. This part of the park is also closed for wildlife migration. There are wolverines that travel from Canada and pass through right near Swift Current Lake. This is during construction. This would be maybe a May or June photo, possibly April. It snowed in until summertime. I don't think I've mentioned it yet, but the hotel was open the entire time that we did the project. I should say it was open during its normal guest season, which is in the summer. And so this is a snapshot out of the spec book, and it's defining the types of noises that are affiliated with construction, like backhoes and jackhammers, and it states an allowable decibel level for those types of activities, whether it's day or night. And then each construction phase of the project required a new drawing sheet in terms of staging and parking and whatnot for construction. And then cell phones don't work at the hotel, and the internet's really shoddy. So during construction, it was I guess, a challenging process. The owner's rep would drive down to the town at lunchtime, call Brett or I with a question, which is the equivalent of an RFI. We would have the afternoon to formulate an answer, email it to him. He'd pick it up in the evening, print it out, and bring it back to the hotel in the morning. This is what the hotel usually looked like when we did our investigations in the shoulder seasons. Pretty cold. Okay, here we go. Three things we're looking at. Deteriorated gravity systems, overstressed gravity systems, and then the lateral force system. These are sort of miniature case studies, so to speak, as we continue in the presentation. I'm going a little quickly because I see I'm taking a lot of time. One of the biggest deterioration issues was deteriorated basement level floor framing. It was a walkout basement, remember, and snow melt was running under the building. It was a very shallow crawl space. And then, over the years, as systems were replaced, lots and lots of notched joists and studs, that sort of thing. We had some pictures that helped us decide where to look. These are the types of things we found, soils that had migrated in the crawl space. You can see that that's a broken girder. This was a sort of unpredicted discovery, deteriorated wall framing. We thought that was covered in the previous siding project. Once we had a handle on the issues, we had to come up with the repairs. And there were two types, so condition specific. This is one particular beam, if you can see the belly in it, and some dry rot at the end. So we sistered it up, epoxied the end, put a prop in. And then a lot of our gravity work was more prescriptive. So we're giving guidelines to the contractor on how to deal with notched framing, what requires headers, what requires sisters, what requires replacements. And then we also made a plan for all the new utilities. So in this particular photo, we've got furring strips where the electricals run. We've got plumbing going through the acceptable holes in joists, and then the fire suppression was dropped below the ceilings. Here's a case study for the dining room. That's the big space with the chimney at the end where the ceiling was put in. And then there's great big trusses that span across, and then they bear on these window jambs. And then there's the great big windows with views to the lake. These stud packs and even the mullions were significantly undersized for wind loading. So this elevation view describes how that's all reframed and the framing's enhanced. This picture is one of the truss bearings, and it looks like it's on a 6 or 7 ply stud pack. So here's that dining room again. This is what it looked like when we started the project. This was the vision that Anderson Hallis came up with. This is what we had in terms of existing documentation. This is during construction, ceiling framing still installed. More construction. These right here are actually related to the ventilation system. And then the trusses are wonderful. I mean, you could tell they were designed by the Great Northern Railroad. And in terms of the roof framing for this particular part of the building, the trusses calced out, and all we really did was just add intermediate purlins between the existing purlins. Here's the dining room when it was all done on the outside. And this very much resembles the historic photo, if you remember from the very beginning. Here's another case study related to the gravity system. And I should mention the design load too. You know, there's no building department to call and ask what the snow load is. So the National Park Service had done a snow study for the park and indicated a ground snow load of 180. By the time we took the reductions for slope, and then we actually had a lower importance factor because the building's unoccupied in the winter, it was around 130 pounds a square foot. This tied and propped rafter system, you know, didn't figure, so we added some additional props down to our bearing walls. And this is what it looked like when we were done. You'll see later that the corridor wall was a shear wall, so we're extending those shear walls up to the roof diaphragm to pick up load. Here's a collector in the area on the outboard of the shear wall. I hope I'm not going too fast, everyone. I just want to make sure we have time for Brett's part, which is really interesting. So Irina asked that we talk a little bit about code compliance, and I thought maybe we'd pause here before we switch from the gravity system to the lateral system and just talk a little bit about code compliance for this project. There's a few points I wanted to make. The first is with the National Park Service, the authority having jurisdiction is actually the U.S. government, and the Park Service has structural engineers on staff. So, you know, along the way, we're collaborating with the Park Service on what the appropriate loads are and what the appropriate approaches are and what the right code interpretations are. You know, if it was just a structural job and we did sort of a careful dissection to put our new systems in, it could have been classified as a alteration level 2, but with the sort of comprehensive fire sprinkler and electrical and accessibility, plumbing, and so on. It really was an alteration level 3 per the work area method. We did have a code consultant on the team, and they helped quite a bit in terms of the egress and accessibility. And that's it for this slide. Oh, this area right here. I think what's important is we took the time to really understand all the structural systems in the building. There wasn't anything we didn't look at, and so we could make informed decisions. Okay, bear with me. Another one of those things popped up. I'm going to do what Richard showed me. Here we go. Getting the hang of it. A few more points about code compliance. I think the park's perspective was this. It was basically a once-in-a-lifetime project. They were putting a lot of money into it. In a lot of ways, it was a gut. A lot of the finishes were moved, so they'd asked that we bring all the systems up to current code. And by and large, that's what we did. There was an exception, and that was the lateral system for the lobby. It has a sort of open floor plan, and it's an iconic, and you would almost say sacred space, where we couldn't put frames. And so the only way we could really get there was to use 75% of the lateral forces, which is permissible per the IEBC in the case where it's a voluntary seismic upgrade. And then for whatever young engineers are on the call today, I thought it'd be worth pointing out my perspective, which is this. I think the right thing to do is figure out what the building's doing and what it needs, come up with the right answer, and then look to the code to see, you know, how you can make that judgment work and be code compliant. So I don't think it's worth getting too worked up about floor joist or, you know, a typical rafter, but we want to pay attention to things like unreinforced masonry chimneys and parapets in seismic country, or tying of masonry walls to diaphragms or scissor trusses, things that would things that are prone to fail and that would be a real life safety issue. Okay, here's the introduction to the lateral system part of it. And this was probably 75% of our work, if not more. We treated each section of the building separately, and that was really just due to the fact that they were all built differently. Interesting thing in the guest rooms was there was a number of partitions that roughly stacked from floor to floor. But they were surfaced with something called sacket board, which was a precursor to gypsum board. And we did some research on that material and learned that it was brittle and failed quickly and not with ductility. And then during some of our probing and investigation, learned that those walls in the guest rooms actually didn't stack exactly from floor to floor. They were just roughly stacked. So it became a challenge to justify what was there. And you'll see we introduced a new lateral system. It's pretty windy there, and I can tell you that just from being there in the fall and getting gravel in my eyes. It was from wind blowing across the lake. Again, it doesn't show up in the wind map, so we relied on a study the park had done. We came up with 110 miles per hour. That's allowable. And in terms of seismicity, we're up here in the yellow, so it's moderate seismicity, more than around here and less than in California. And, oh, here's a couple facts that are interesting. So just on the north half of the building, the first phase, we introduced a total of 22 new lines of resistance or shear walls or frames, because everything that was there originally was, not specifically designed for that purpose. Again, it was empirical. And then to put another point of perspective is, this chimney is about 50 feet tall and weighs close to 500,000 pounds. So if you do the math on the seismic, it's pretty big forces we were dealing with. And that particular chimney we did strengthen. And if there's time, I'll show you that at the end. And then, of course, all of our work had to be coordinated with the other disciplines. This is that T-shaped Annex 1. These are all guest rooms. Here's the big chimney we were just looking at. There's another chimney that doesn't really read right in the middle. And these are the 4 new lines of resistance we added to this wing to give it the strength it needed for wind and seismic. This particular section was actually governed by wind. It's all wood framed and it doesn't have much masonry. But what we found was quite a bit of load accumulates in a 5-story building, and our aspect ratios were fairly unfavorable. So here are these 4 walls in the plan view. And then we strengthened from the inside on the end wall. And then the corridor wall became our shear wall. And then we gave some credit to the exterior walls that had diagonal sheathing on them. Here's the cross section. So this is from the original drawing. It's pretty close to what was built. And this is the wing that had tilted. And a previous emergency stabilization measure had put these retaining walls in, and then there's some counterforts here that really made it hard for us to get shear walls on this side of the corridor. It was just too congested in this crawl space. So we picked the far side. There's a doorway, and then we have a lot of utilities running through this little gap between the end of the shear wall and the corridor wall. Lo and behold, we could only get the upper stories to work in wood, and then we transitioned to reinforced concrete. It's like a 5 or 6 to 1 aspect ratio. And then, as you'd imagine, the tension forces get pretty big at the bottom. So for this wing, we're using micropiles to resolve the tension loads at the end of our shear wall. Even the wood shear walls have some hardware that's a little bit more than I was ever used to dealing with. Some of these are double 6x6 studs with the Simpson high strength anchor rods that tie full height. And then I mentioned before, the roof had already been dealt with, so we had to respect the existing diaphragm capacity of the roof and the floors. So you'll see we're adding a drag here so that we don't overload the roof diaphragm. And then the spacing of the shear walls was also largely governed by the diaphragm strengths. Getting a little off script here, but I hope everyone's getting the gist of it. Here's some of those shear walls in Annex 1 during construction. Like I said, the walls that were here formerly roughly stacked, but didn't really stack. So we asked the contractor to sort of pick the average center line and locate their new shear wall in that average spot. It's concrete up to this level. And, oh, and here's the micropile rig, which they drove in to put the micropiles in before the grade beam / pier cap. Here's an example from the dining room that my boss Dan did in the first phase. There's 2 chimneys. And so this is the big dining room chimney that we've seen in several of the photos, and here's that kitchen chimney. This shed was removed so that visitors could see the chimney from top to bottom. Here's one of the 2 flues in that chimney. Here's what it looks like in the existing drawing. And then here's what Dan came up with. So this flue served a abandoned boiler in this lower level, which is where the shop was, and then the dining room's up here. Of course, everyone wanted to keep this flue operational for the guest experience. So this flue was abandoned and recruited to be part of our lateral system. It's reinforced and grouted. There's some stone demo to be able to access the opening. And then on the opposing side, the stones were labeled and deconstructed, and then this reinforced concrete shoulder and cord was installed, and then it was refaced with stone. So in terms of the lateral system, this fellow became a shear wall in plane, and then out of plane where it's much more slender. The diaphragms actually collect the load and distribute it, downstream to other shear walls. There is this. This is a duplicate, but this is more of that strengthening work around the windows. I can let these pictures do the talking here, but let me point out the 2 pictures on the left. This is putting the reinforcing in the boiler flue. This is that slot cut into the shoulder. This is the forming for the concrete. Oh, here it is. And then there's that window work. These are pictures of some challenges. This is a shear wall very central to the building, and the crawl space happens to be very deep here, so the contractor didn't want to deconstruct this floor. The micropile rig is supported by shoring in the crawl space, so it can install our micropiles and pier caps down here. There's plumbing and utilities everywhere in this hotel, and while they were mostly being removed, they were in the way of assessing things. A lot of the framing had been modified because of them, and then in the new design we had to find chases for all these sorts of things. And then these are the reframed exterior balconies I mentioned before. This is a stone masonry chimney that was shotcreted, and yet another interference to deal with. I think that's it for me, and next up is Brett. Thanks for bearing with me. I was a little bit nervous, but I'm feeling better now. And then when Brett's done, I'll come back and wrap it up, and then we'll do questions. Yeah. Okay.
All right, thanks, Ian. As I'm sure you can see, he's the brains behind the operation, really. He's been involved from the beginning due to retirements and or going on strike or something of some of the senior guys in that first phase. They needed replacement engineers, so that's kind of what I am, is the scab engineer. He tempted me in with promises of these amazing site visits, you know, pristine, beautiful environment. He followed through 100% on that. It is really, really, it's an amazing place. It's amazing location, and it's beautiful that it got saved. He did not mention that they turn off all the plumbing in the winter when we were there doing our site visits. So the nearest toilet was a vault toilet, quarter-mile or so away across very cold, mountain goat infested parking lots. But I've forgiven him for that. I'm not sure I've forgiven him for the complications of the lobby. This view here is from the original drawings, and that doesn't look so bad, right? It looks like it may be a pretty straightforward old building, but that really isn't the case. So I'm going to go to the next slide, which is a cross-section roughly through the same area which we did after I got involved, and you can kind of see there some of the difficulties. The big atrium in the middle, of course, it was laterally very difficult. Shear walls, or walls that we could use as shear walls, coming down to joists. Even the exterior of the building on two of the sides didn't go all the way to foundation. It came down to rows of log columns. As Ian mentioned, we were working with 180 PSF ground snow load, seismic design category C. I'm not aware of any earthquakes in the vicinity of Many Glacier, but there have been on the west side of the park. In 2017, there was a 5.8 magnitude. So even though it hasn't hit there, it is a real concern and a real issue. You can see, similar to what Ian was saying earlier, that we have a lake level down here, basically a walkout basement retaining on the mountainside and then open out to Swift Current Lake. And then there's the lobby level, which is really open. Not a lot of walls, not a lot of continuity there for us. And then there's two levels of full levels of guest rooms, and then there's a fourth level actually in a couple locations of small staff rooms, kind of tucked up into the rafters. And then, of course, the roof, which he talked a little bit about earlier, and we'll talk a little bit about it later. So that's a photo during construction looking across the lobby. Those chains that you see in the foreground, those are supporting a steel chimney that goes to a fireplace in the lobby level that's open 360 degrees. There's chains other places that are used as tension members. Sometimes they were kind of wrapped in logs that have been split and hollowed out. Most of the logs here were local, but these columns were not. They were dug fir timbers brought in by Great Northern, and brought in from the Pacific Northwest. And I know Ian touched on it, but I kind of want to loop back and talk about the history of this lobby, which is really kind of the iconic piece of the Many Glacier Hotel. I mean, built in the 1910s, that was before car tours and was the established mode. So this was imagined with people arriving by rail to the park. And then there's a variety of these lodges throughout the park, different places. And the intent was that you could walk between them, hike between them, and your luggage would be carried for you, you know, by cars or trains or whatever it was. So you could hike from lodge to lodge, spend a night or 2 nights, do the activities and hike to the next one. So it's a really different concept of vacation, kind of modeled after what people did in the Alps in Switzerland and Germany there in Europe. But the lodge has adapted really well to the changes of time. And there are still some of the lodges, other hotels or places to stay in the park that are only accessible by hiking or only conveniently accessible by hiking. Ian's worked on some of those as they've needed repair. But it's just really a neat slice of Americana, just a different day and age and time and approach to vacationing that we've moved on from, but it's nice to see pieces of that preserved and celebrated. Going back to those columns, we thought they were continuous from rafter to foundation, like Ian said, but we'll get back to them a little later. We were actually wrong about that, and that wasn't very fun. So we rendered this model using RISA floor. You can see the logs and some of the dimensional lumber there. The yellowish plates are our exterior dimensional lumber stud walls that we wanted to use for shear walls as much as we could. You can see the unreinforced masonry there in blue. And when we built this model and started running it, honestly, it didn't run well with existing loads. There were instabilities, there were deflection problems, members, especially in the floor framing, members that were just overstressed and didn't have capacity for modern design codes. And the renovation in the 1950s really didn't help. It made things worse. And then, as you mentioned, there really wasn't a discernible lateral system design. It was empirical, and even empirically, it had some challenges. I'm guessing that it has been close to that 180 PSF ground snow load at multiple times during the park. You've seen the pictures from Ian of the building retaining snow. I think likewise, it's probably been pretty close to its wind loads and it hasn't fallen down, so there's some redundancy there. We couldn't get it to calculate cleanly, so there's no doubt some structural pipes and ducts and conduit helping out in the building. So our primary focus was to strengthen the lateral system. At the same time, we took care of a lot of the life safety things for gravity loads, but the primary focus was the lateral system. And we did have to be, everything was negotiated. There wasn't a lot that was permitted by the combination of the National Park Service, the architect, the State Historic Preservation Officer, and also by the budget. I know that a similarly constructed project at Yellowstone several years ago with a bigger budget and granted higher seismicity, they actually shored up the building, took out the logs, hollowed out the logs, and then used those to clad a structural steel moment frame system, but that just wasn't in reach for us. And so in the end, for the lateral system, it was, like Ian mentioned, it wasn't get it to what the current code is, it's what can we get it to within the parameters we have. Starting with the diaphragms, going to collectors and cords, just from there all the way down to foundations. How much can we strengthen them? How much can we improve them? And at the end of the day, what does that get us? And as Ian mentioned, at least 75% at our worst point of current seismic loadings. Normally, I wouldn't be very happy with that. That doesn't give me a warm and fuzzy feeling. But with the fact that some of that seismic mass was contributed by snow loads, and the hotel is not open during the winter. When we back that out and remove that from the equations, we felt like we took care of the life safety issues when the hotel was occupied, and then our worst case would be building damage when the hotel was not occupied, but not human life. And so our list in our general notes of our lateral systems, it kind of reflects that. We've got wood shear walls, concrete shear walls, some braced frames, and then everybody's favorite cantilevered log columns. So let's go kind of level by level. We'll start at the top because that's really the most similar to the other buildings. It'll get more interesting as we go down then, hopefully. Here at the roof, we couldn't do anything above the roof. As Ian mentioned, they had re-roofed, re-shingled, and this wasn't your typical asphalt shingles. They were high-end specialty shingles because of the exposure, because of the because of the conditions out there, and it was just off the table to remove that. And similarly on the bottom, the tongue and groove decking is visible from the lobby, and it's iconic. It's really not touchable along with the logs. Actually, the log rafters and the beams calced out pretty well, similar to other areas of the hotel, which was good. I don't think they would have let us do any work on them. So we primarily added shear walls and improved connections. Some of the connections were just friction connections, and a lot of the other ones, would have been brittle failures. So we made them as ductile as we could, and did the best we could with what we had available to us. We also did some additional connections at the chimney. We'll talk about that a little bit later, but it's similar to what Ian had mentioned in chimneys in other parts of the project. So then we moved down to the second and third level. This is the second level here. Similar things. We had to sister quite a few members to get up to current live load capacities. Partially because some of our shear walls, particularly at the second level, were sitting on joists and framing like that. And then obviously because of that, we really had to work on the diaphragms. So we were able to sheathe above the joists everywhere, and in some locations we were able to sheathe the bottom of joists to help us develop diaphragms that could move the loads around. And we added blocking. I mean, miles and miles of blocking. The contractor had laborers that's what they did for weeks on end, was cut blocking, and other laborers who installed it. They must have really hated me. But that may be a theme of their labors throughout this project. We also had similar issues of repairing floor joists as different trades had come through and blown holes or completely removed sections of joist. That was similar to what Ian had talked about. And then there's a part of this project, a part of the hotel that they used to call Stagger Alley. It came off of the lake level of the lobby and then went into Annex 1. And the lake level lobby was where cocktails were served and dinner and dancing and that sort of thing. And so part of it was perhaps some of the guests were inebriated as they made their way back to their rooms, but it really wasn't their fault, just from some of those factors that Ian mentioned earlier. The floors were not, they had cross slopes that perhaps you might not expect. And then in the second and third levels here, we had our own little stagger alley. In the 1950s, as part of the renovations, they removed some columns and tried to strengthen some of the existing structure. It was making room for a gift shop in the lobby. But the members just weren't stiff enough. They weren't strong enough. It had settled several inches in the southwest corner down in this area, to the point that all the doors to the rooms here were diagonal cut at the top and bottom to be able to open and close. And if you weren't paying attention, you could really stumble, you could really stagger here. So we went around and around with the architect and with the Park Service and the code consultant. What do we want to do here? Of course, in a perfect world, we could level it out again and everything would be great, but this is a far from perfect world where all the doors, a lot of historic material had been altered to accommodate the deflections, and we were worried about straining connections in adjacent members. But on the other hand, leaving it as it was kind of rough. We could stabilize it in place so it wouldn't move more, but it's going to be a potential trip hazard. The consensus was to try and get it to comply with ADA, which would have been jacking it about 2 inches in the worst case location, so to get ADA slopes and cross slopes. And we started that. Nobody was very excited about it. And we did it in lifts of 1/4 inch. And we stopped after, it was either 3/4 of an inch or an inch, just because the behavior of adjacent materials and adjacent connections. It was getting to where it was displacing things and we were worried about it rippling through the rest of the structure. So you can still go there, you can still stagger down that alley if you want to. Just a couple quick photos from some of the things we've been talking about. I'm sure this looks familiar to all of you, but we're connecting our shear walls from level to level. Each one of those details is different, it seemed like, everywhere in the project because each one had slightly different existing construction. And that's a close-up of the hardware. I think, as Ian described, it's stiffer, heavier than what we normally see around here, but more typical in other parts of the country. And then here's a shot. You can see in the background there, creating shear walls along the exterior walls. In the midground, you can see the sheathing going in at the floor level, and then you can see removing finished material so we could work on the strengthening the beams and the connections to those columns. As I mentioned earlier, we could sheathe both the top and in most locations the bottom, although we had to be careful on the bottom that it didn't create discontinuities in the ceiling line that would be noticeable. So that takes us down to the lobby level, and that's where things start to get a little bit more exciting. There's a lot of windows in the lobby. I'm forward to a picture of one of those here. That's a big window that didn't have much of a jamb before, and so we had to replace and strengthen those. There's really no place to have shear walls, really. There's a few places where there's continuous walls, and we certainly utilize those, but in the end, there's a lot of load going into those cantilevered log columns. You can see we're doing a lot of work on the diaphragms, trying to strengthen them and be able to move that load around. And you can see where the replacement twin spiral staircases down between the lobby level and the lake level came in. It was really beautiful. The craftsman who did that made it look amazing. I kind of was sad that they didn't put in the fountain and the rock piece that was in the original section that Ian showed you. And one of the old timers up there told me at one point that there was a pipe going from there out to the lake so that trout could swim in and out. I think that may have been an old wives' tale, but it's a nice idea, and I kind of wish it were true. We had to strengthen a few members here for gravity as well, so particularly in this area where that fireplace, that 360-degree fireplace came down, and also a little bit over here where the gift shop had been. Something you can't really see here, I mentioned it earlier, there is an exterior deck on two sides here, so our perimeter walls did not actually come down to foundations. They came down to a combination of log columns in the lake level and timber beams. Again, that was something that had been done fairly recently. We were not allowed to touch the decking and, more important, the waterproofing beneath it, and that made me sad because it's a Trex type deck and the supporting joists are too far apart, and so it's got this wavy appearance. I kind of wanted to put a little placard there saying I really wanted to fix this, but they wouldn't let me. But on most of our trips, that's where we ended up last thing in the evening before we headed back to our hotels in Bab or further away. It was just take a minute sitting here watching the sunset. I mean, it's just an amazingly beautiful place. I mentioned earlier that we had a bit of a surprise in the columns not being continuous from rafter down to foundation. They were cut within the depth of the floor structure at the lobby level. So we had basically no continuity between above and below. In some places, we actually had to add yet more blocking to give the upper columns adequate bearing. And they wouldn't let us have anything visible at the lobby level. It was completely off the table. They did let us strengthen and add some collars at the lake level. And from those, we ended up working with Portland Bolt to get some custom lag bolts made and the contractor made some jigs and was able to lag up through and connect the two columns for the loads we were anticipating. You can imagine as part of that, we were trying to, as hard as we could, to get the loads from that lobby level diaphragm down to foundation as many other ways as we possibly could. So we ended up strengthening a lot of the beams as well, but always above the finished material or in unobtrusive ways that the architect found acceptable. So down here at the lake level, we were allowed to put in some concrete shear walls in unobtrusive places. Up here by a restroom core, over here by where they were relocating a cafe. And they also let us put in a couple of steel X braces here, 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 and then over there. The other challenges that we had here is, as Ian mentioned, there was a lot of groundwater movement going underneath the framed wood floor. In the 1950s edition, when they had been playing around with some of the columns, they put them on concrete foundations. Many of the others were still on the original stacked stone foundations. In the end, the Park Service decided to replace the framed wooden floor here with a concrete slab on compacted gravel with a bunch of drain lines going underneath it. So we protected the bases of the columns as best we could. At the time of our investigations, they wouldn't let us do any kind of destructive testing of the log columns. So we just had to note that during construction, the contractor needed to do some demolition, see the condition, see how bad it was, and see what we needed to do to fix it. This is just a slide from our model showing the log columns and the braced frame locations. And that's one of the X braces that we were allowed to put in. They're founded on, similar to other areas, on micropiles with concrete pier caps. You'll notice that they don't actually go all the way to the log columns. That was at the request of the architect to separate that historic element from these newer elements. So after they started construction, sure enough, we had rot in about a half dozen of the logs. So we sent one of our, I guess he was a young engineer then, he's now of course old and mature, Ty. He spent a couple days with a piece of equipment called a resistograph that's part of Ian's box of tricks, and it measured the torque differences as we drilled some pilot holes through these logs. So based on the graph of the resistograph, we could determine the extent and location of the rot. And with those 4 that we had to remove, that's one of them. You can see that's rot. And it was primarily in those logs that had been founded on these concrete pieces during the 1950s. So we ended up having to shore those individual columns up, and with a chainsaw then we removed the rotten part, hollowed it out, and then replaced the rotten part with a steel post, and then took the shell of the wood, which was still good, and clad it, and it really turned out pretty well. If you're looking for it, you can find it, but if you're not looking for it, you won't know it's there. So there's one of the posts coming in. The chimneys, there were 2 chimneys in the lobby. One was that metal chimney, which obviously wasn't really an issue, but the massive stone chimney by the front desk, it had fireplaces at the lake level and the lobby level, and they wanted to keep the lobby level flue operational for the guest experience. They weren't as concerned about the lake level, so they allowed us to grout and reinforce, or reinforce and grout that one. We still, second floor and up, had to tie off to the floor diaphragms at each level and transfer those loads into the diaphragm and through the structure. At the lobby and lake level, it was massive enough that we also ended up similar to what was done in the other area, in the dining area chimney, with some drilled and grouted holes and then recovered with the facing stones. During construction, the grouter got a little bit ambitious with his lifts, and we actually had a blowout up about between the second and third levels, but fortunately all of the shoring and protection was in place. Nobody was hurt. It was just a wall that had to be rebuilt, and there was a lot of cussing involved. And then there's a picture of them drilling into the chimney to be able to reinforce and grout that to strengthen it. So this is the finished product. I actually couldn't see all of Ian's slide. I'm not sure if he showed this picture or not, but it's really it's a beautiful space. This is taken from the opposite end than the construction picture, but it's beautiful. It's for all its challenges and frustrations. When you go back and are able to see that finished product, it was worth it. And then this is the bottom of those spiral staircases, which again are just beautiful, and I was really happy and proud to be a part of that. So now I'm going to give the time back to Ian, and he'll wrap a few odds and ends up, but thank you for your time.
Thank you. Okay, can you hear me okay? Obviously, this could be a longer program, so I'll go quickly here at the end. I will tell you if anybody's curious about anything that we kind of gloss over, happy to talk about it later. You know, it's been fun to refresh my memory on this project the past week, getting ready for today. So let me go through the end quickly and make sure we have time for questions while everyone's on the call. And I'll just try and highlight, I think, what's the most interesting, and I guess what may be sort of a lesson learned or that sort of thing for any younger engineers on the call. So Annex 2 is the one down at the south end. It was the last part of the hotel that was built. Christine did the design. Very similar to Annex 1. Let me just point out what's different. It had 4 chimneys, you know, serving, they weren't, you know, they were furred out with and plastered, so they weren't visible. They were utilitarian. And as Brent said, on this second phase, we were very, very much budget constrained. So we elected to take this seismic mass out of the building and remove those chimneys. It greatly reduces, you know, what forces we have to deal with. And the tops of those chimneys had already been lopped off in the attic. So it really wasn't a loss of historic fabric, or at least historic fabric that people can see. The other thing that's different and interesting are these bump outs at the cross gables. And something I learned in one of those woodwork seminars from, I think the fellow's name is Terry. You know, you want to have your cord at the same line. So these black lines are indicating sort of a cord we're introducing with steel strapping and blocking, so it behaves like a diaphragm without irregularities. And then keynote 9 here are drags. So again, we're trying to respect the capacity of the existing diaphragm, which thankfully was diagonally sheathed. So we get a pretty good number for that. The walls were diagonally sheathed. The roof was horizontally sheathed, but that roofing project had put a thin layer of panel sheathing on top. So we had decent diaphragms to work with. Sheathing a shear wall on the interior is easier said than done. This is sort of the simplest of all the details we came up with, where we basically transfer our shear through some extra blocks or plates through the rim and then down into the next level. There were dozens and dozens of iterations of stuff like this, especially in the lobby. For Annex 2, we used both corridors instead of just one. Obviously, that's better, and it was also because we reinstated the light wells in each of the rooms, so we had less shear piers to work with. We needed both walls. This is what it looked like when it was done. The historic board and batten wainscoting. Grade beams, shear walls. The chimneys, so I think there ended up being 7 or 8 chimneys in total. Each one was treated uniquely. Brett passed along the biggest lesson learned. Grouting a flue is pretty common practice as a reinforcing strategy. You do have to be very mindful of your lift height because they can blow out on you. This is the one we touched on before, the annex chimney. This was reinforced and shotcreted. It's tied into each diaphragm. In the short direction, it becomes our shear wall. In the long direction, a lot of work in the attic to pick up load off the roof diaphragm, and then micropiles and grade beams. The concept was standard. The detail was different at every condition. This one's pretty interesting. The chimney really necks down between the first and second floor. So it's just a skinny square, unreinforced masonry chimney sticking 15 feet out of the roof. The flue had to remain operational for the interlocking lounge. So Dave Hotteshell, if there's any old timers on the call, might know him. He and I came up with this idea. So this is a steel pipe. We dropped it with a crane into the flue and then sort of grouted the annulus and reinforced it to give it, it gives it the ability to act like a flagpole once it cantilevers through the roof diaphragm. And then that's the kitchen chimney. This is the one you see in the pictures where Dave and Dan are sitting on top. That one was pretty standard, good aspect ratio, and the sort of frightening top of it had been removed before. Oh, one other thing I forgot to mention, the contractor was called Swank Enterprises. They were out of Montana, and they did the emergency stabilization work before our team was involved. They did phase 1, and like I said, they did it very inexpensively, relatively, and then they won the contract for the second phase. So the contractor was familiar with the building. They were very familiar with the Park Service process, and that was actually a big deal because these construction seasons, it was moving so quickly. And we made relationships with those people. They did a nice job. And this is the end, just a handful of photos. I think Brett did a great job of characterizing how neat of a place it was. Here's Swift Current Lake and the lobby and the deck. That's when we were done. This is the interlocking lounge when we first started. Here it is when we were done. There's that chimney. It's got the pipe in it at the top. And then this is the photo you see all the time with different lighting conditions. In closing, I'll say it was a terrific project. The Park Service, I know, was happy with the product. If you visit the hotel, it'd be hard to find any of the structure unless you're really looking for it, and in a few exceptions. It was our privilege to work on it, and we're grateful. Thanks for watching the presentation. Oh, yeah.
Thank you, Ian, and thank you, Brett. That was a fabulous presentation. We're going to go through just a few exciting announcements about upcoming SEAC events, and then we'll open the floor to questions. I believe at this point, Richard, we only have one question in the chat. Is that correct?
They're coming.
They're coming. Okay, fabulous. Keep them coming. First, we have an event, May 13th, a Thursday. SEAC is going to, in lieu of our traditional WebEx meeting virtually, we're actually going to try to meet together in person once more. We're thinking outside the box. We're thinking about nature. So anyone who's interested in potentially joining and volunteering with the SEAC Education Committee is welcome to attend. This is an invite to prospective new members. For those of you who are unfamiliar, the SEAC Education Committee is primarily focused on putting together project presentations such as this one, site tours. The fall seminar is our keystone event, as well as PE and SE test prep. So look for more information about this exciting event. It's going to be at the North Mesa Trailhead, and we're going to have a little hike, refreshment and hike for those who attend. Next, we have an August project presentation. This is about McGregor Square. It's an exciting mixed-use development happening just southwest of Coors Field in Lodo. 659,000 square foot development opening in phases starting this spring. It's going to include everything from a food hall to a hotel to a giant outdoor plaza. And I think we can all agree that by August, we will all be looking for a good distraction from Rockies baseball. Lastly, the SEAC Younger Members Group has an upcoming event, also Thursday, May the 13th at 6 p.m. This one's going to be virtual. What's gray, rock hard, and always cracks? That's concrete. So this presentation will look at cracking in concrete from the perspective of the basic nature for cause and effect and deliver ideas for mitigation and repair solutions. The presenter, James Beatty, has been in the concrete industry for 30 years, dealing with both cast in place and precast concrete elements. Okay, so let's get to our Q&A. Okay, yeah, I can see it. Thank you. Thank you, Richard. So let's start with Ray Donner. His question is, you mentioned that the columns between the windows in the dining area were under-designed for out-of-plane wind load. Were there any related signs of unacceptable movements or damage prior to the updates and improvements? This is going to get a little tricky. Ian, I think I might have you sit down and we'll have you go through the questions. And maybe we can have Brett up here as well. Okay.
Why don't Brett and I sit down? We're both vaccinated. Take our mask off. To answer the question that was asked, I don't recall seeing a distress issue, so I suppose they were, load tested from a wind and snow point of view. It was just the charge of the project to analyze all of the framing and things that were significantly overstressed by calculation. We did upgrade, so that was one that identified itself through analysis and not through a defect, if that makes sense.
Question would be, how many total hours were spent on the project?
Oh, geez.
I'll let you answer that. I have no idea. A lot.
Yeah, a lot. I mean, thousands.
It was a 12-year design phase, or 12 years in design. So
Um, yeah, you might have to email me that one, and I could. I think we have something like 15 project numbers, and I could add them up for you. You know, it does remind me of something. One big challenge of this project was just sort of keeping up with the drawing production. So we'd go to the site and do a few days of investigation and have, you know, a handful of meetings with the various other consultants and architects and park people in the hallways. And, you know, you come back from the plane with pages and pages and pages of notes and ideas and pictures. And then, you know, poor Dave, you know, we're handing him, you know, dozens of redlined sheets of drafting to pick up. So, you know, while it's easy to conceptualize the repair, to actually get all these things detailed and keep up with it and get to the next phase was a challenge.
next question is, can you describe the communication process between JVA architect, contractor, and the park's weekly meetings?
Is that during construction?
Both, I'm sure.
Yeah, it was design, bid, build. So we didn't speak with the contractor truthfully until the construction phases. And then, you know, in DD, CD, we're speaking with the architect every day. And, you know, formal meetings were probably every couple weeks. The schedules aren't terribly accelerated, as many of you are probably used to in, you know, private development. And then with the park, I'll say as sub-consultants, it would be sort of periodic and strategic and while on site. So I guess at each milestone, we would have a meeting down at the Denver Service Center with the park to describe what we were up to structurally, and then you know, park people would accompany us during the investigations, which were in the spring and fall. But most of that back and forth with the park was between the architect and the park.
It's a little bit of a
Phil just asked if any of us ever got to stay a night. I have not. Truthfully, I haven't been back since my last site visit and field observation report. I know Christine's been back. I don't know if she got to stay there or if she stayed near there and just visited. Is that it? Yeah, thanks everyone. Really appreciate it. Thanks for your time. And thanks Irina and Phil and Richard.